Alright, so moving on to our next conic section, we're going to be talking about ellipses. An ellipse is similar to a circle. With a circle, we have one point, and then we find all the other points that are the same distance from that point, and that distance we call the radius. With an ellipse, we're actually starting with two fixed points, and then we're finding all the other points where if we add up the distance from those 2 points to the other points, it's always going to be constant. So we'll look at a little demo of this the next time I see you in class, but for now let's look at the mathematics of ellipses. So our definition here, the set of all points x, y, the sum of whose distances from two distinct fixed points called foci is constant. So again, with a circle, we just have the fixed distance from the center. Here we're going to have the sum of some distances is fixed, and the distances is from the foci. So there's a lot of information here, so you may want to watch the video more than once, and as always, make sure you write down questions and ask them the next time you see me in class. So we're going to have two types of ellipses. We're going to have one where the major axis is horizontal, so that's going to be this picture down here. We're going to have an axis that goes all the way through here. We'll draw that in a minute, and that's the major one is the longer one, so it's going to go horizontal. And we're going to have a major axis that's vertical, so that's this picture here. You can see if I draw a line that goes through the center here, divides it into two halves, our major axis will be going vertical. So if we look at the standard equations, we're going to notice some similarities to circles. So we have our x minus h squared and we have our y minus k squared. Except now we've got some fractions over here. So we have an a squared, we have a b squared, and it equals 1. And then over here, again we have our x minus h squared, our y minus k squared, except now we switch the a and the b. Okay, so over here with a major axis horizontal, you notice that the a squared is under the x, okay, and our x goes left and right. And over here our a squared is under the y, and our major axis goes up and down the same as the y-axis. So knowing the standard equation, there's certain pieces of information that we can pick off right from that equation. So we can find the center just like we did for a circle, so the center is going to be hk. We can find the length of the major axis. Okay, and we'll talk about what that is in just a minute. So if we figure out what a is by taking the square root of a squared and we double that, that will give us the major axis. If we figure out what b is and double that, multiply by 2, we're going to get what the minor axis is. So the minor axis here would go from here to here, and the minor axis over here would go across there, and we would be going through the center. And then the foci, again, we'll fill in our picture here so we know where everything is. The foci are going to be on the major axis, and they are c units away from the center, and the way we find c is by doing a squared minus b squared. So it looks a little like the Pythagorean theorem, except that it's a squared minus b squared. And then we've got that b is greater than 0 and a is greater than b. Okay, so basically this statement here is saying that a is larger than b. A is always larger than b. A is always larger than b for an ellipse. Okay, and then when we come over here to major axis vertical, we've got the same center, we've got the same major axis, we've got the same minor axis, we've got the same foci. Again, a is going to be larger than b. So if you're thinking ahead and you're going to try and figure out just by looking at the standard forms which way it's going to go. Is it going to go horizontal? Is it going to go vertical? You look and see which one of these values in the denominator is larger. So since a is always larger, if the larger number is under the x term, it's going to be horizontal. If the larger term is under the y's, it's going to be vertical. Alright, and we'll talk more about that in a little bit. Alright, so moving on. Let's fill in some stuff in our picture here. We're going to have a center. Okay, and we're going to call that O. So that's our center. Okay, we're going to have foci, so we'll draw these in, and again I'll show you where these, what these are used for when we do our demonstration in class. So I'm going to call this E and F. Okay, and these are our foci. Okay, one of them is a focus, more than one are foci. Then I'm going to have an A over here, and I'm going to have a B over here. Okay, and these are called vertices. Alright, and then I'm going to come over here along my minor axis. I'm going to have a C, and I'm going to have a D. Alright, and these are called our co-vertices. And then these 5 points here are collinear, so let's see how well I did here. If I draw a segment that goes from A to B, not too bad. AB, this is called our major axis. And this actually here should be CD, so let's put CD in there. So CD is our minor axis, right? And then A and B, these are very, very important. So A is basically the distance from the center to one of the vertices. Distance from center to vertex. Okay, it's half the length of the major axis. Okay, so that distance here, it's going to be A, goes from here to here, or A is going to go from here to here. So from the center to either vertex. A and B are vertices. So if we go from the center to the vertex over on the right, that's distance is A. If we go from the center to the vertex on the left, that distance is also A. Alright, and then for B, it's the distance from center to co-vertex. So this would be half the length of the minor axis. Alright, so if we want to label that on our picture here, let me switch colors. That's going to go from the center up to one of the co-vertices, either that way, and this will be the same distance from the center to one of the co-vertices over there. Alright, so we've got distances A and B, and we're also going to have another distance C. Alright, C is going to be the distance from the center to the foci. So that distance from there to there, and this distance from there to there. So basically we're looking at segment OE, that distance is C, and segment OF, that distance is C. Right? And there's a relationship between A, B, and C. Alright, and that relationship is that C squared is equal to A squared minus B squared, which we saw up at the top. I'm just reiterating because that's important. And then let's put down what C is. C is the distance from center to focus. Right, so again in our picture, OF and OE are segments of length C. Alright, so again, there's lots of different parts. The more problems that you do, the better that you'll get at this. So make sure that you're working on the problems. Alright, so again with our major axis vertical, we're going to have the same points. We're going to have a center. We're going to have vertices along the major axis. So this would be our A and this would be our B. We're going to have vertices along the minor axis. So this would be our C and this would be our D. We're going to have foci, E, another focus, F, and then this would be our center, O. So then we would have our major axis, we would have our minor axis, and then all those other distances. So for here, A would go vertical, and B would go horizontal. So B would go from here to here, or from here to here, the distance from the center to the co-vertices, and then C would be the distance from the center to either of the foci. So we're just taking this picture and we're turning it to the side.